And it's code in the D to give the keyboard a punch. Then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? Program it right. Nothing ever happens in this.
In this video, I'm going to show you how to use Stata to create an additive index. I'm going to use an example from the General Social Survey. Respondents were asked 10 different questions about their confidence in various American institutions. We're going to start by looking at 3 of them just to see what the numbers look like and how the index is going to work, and then we're going to expand it to use all 10. Here's the 3 that we're going to look at. The first variable is called CONBUS, and that stands for confidence in business. The second is labor. How much confidence does the respondent have in labor? And then finally, legis. How much confidence the respondent has in the legislative branch of the government. Respondents are provided 3 different options or possible responses. Response number 1 is that they have a great deal of confidence. Response number 2 is that they have only some confidence in these institutions. And response number 3 is that they have hardly any. Let's look at a couple of hypothetical cases. A respondent could possibly respond that they have a great deal of confidence in business and in labor and in the legislative branch. This person shows that they have the most confidence possible in all these 3 institutions. It's possible that a respondent could also respond 3 to each of these. The implication that they have hardly any confidence in any one of these institutions. And of course, they might respond either 1, 2, or 3 for any individual, any parts of these. For example, might have somebody who responds 3, 1, and 2, hardly any confidence in business, a great deal of confidence in labor, and hardly any confidence in the legislative branch. Or they might respond 1, 3, and 1. They have a great deal of confidence in business, hardly any confidence in labor, and a great deal of confidence in the legislative branch. What we'd like to do is add these 3 variables up to create a new variable that is an index of one's confidence across all of these institutions, not focusing on any one piece of American institutions. We could create a new variable which simply adds the values of these 3 variables together to give us our index. For example, using a generate command, and I'm going to shorten generate to GEN, generate a new variable, which I'll call CONIDX, and we'll make that equal to the sum of business plus labor plus legis. I'm going to make a little more room up here at the top, and let's go ahead and plug some values in to see if we understand what's going on. Our new variable is going to be called CONIDX, confidence index. And if we were to use this generate command, our first respondent would be given a score of 3. Our second respondent would have a score of 9, 6, and 5. So there's our index. Now, when I call this a confidence index, to some extent this is really a lack of confidence index because larger values represent less confidence. A respondent with the maximum score of 9 has the least confidence in these 3 institutions. A person with the minimum score of 3 has the largest score, the largest confidence in American institutions. This particular scale is now, we can see by looking at these 2 extreme cases, will range from 3 to 9. It's not a bad scale, but remember, you have to know exactly what it is you're measuring. Now, this is kind of an odd scale, starting at 3 and ending at 9. We'd like to have it start at 1 and end at another number. And furthermore, we'd also like to reverse code this. We'd like the larger values to have the implication or infer greater confidence, and lower values, lesser values, less confidence. So we can play with this formula a little bit. We know that if I were to take, and I'm just going to redo this beginning part of my formula, and use a new gen. Something like this. That should do exactly what we want. This new variable, which I'll just list some values over here, 10 minus 3 is 7. 10 minus 9 is 1. 10 minus 6 is 4. 10 minus 5 is 5. So our new scale, our new index, ranges from 1 to 7, with smaller values meaning less confidence in institutions, and larger values, a value of 7 meaning greater confidence in American institutions. You can see that there's 27 different sequences with these three variables. That is, on confidence in business, a person can respond with either a 1, 2, or 3. Confidence in labor, they can respond 1, 2, or 3. And the same for confidence in legislation. Therefore, there's 3 raised to the third power, or 27 ways that we can get different sequences of responses here. We're going to look at a complete index, which will have 10 responses. And so there's 10 raised to the third possible sequences of ways people could respond to those 10 questions. Well, here we are in Stata. I'm going to go ahead and just use the command line to create the variable that we discussed. I'm going to use the generate command and my new variable, CONIDX, and I'm going to make this equal to confidence in business plus confidence in labor plus confidence in the legislative branch, conlegis. I didn't receive any errors. I'll look at a tab of that variable, cross tabulation, or univariate frequency distribution. It looks good. We see it goes from 3 to 9 as we would expect. Now remember, I'd like to reverse this, and I'd like to have it go from 1 to 7. So I'm going to come up here and I'm going to edit this command, and I'll replace this, since this variable already exists, with 10 minus the quantity of the sum of those variables. And we'll tab that. And you can see now it does exactly what I want it to do. It ranges from 1 to the largest value, 1 to 7. That is flipped or reversed, so that 1 means there are 1,424 people who have hardly any confidence in any of those three institutions, and there's 848 coded 7 who have a great deal of confidence in all three of those institutions. I've already created a Stata program that creates this confidence index for all 10 variables. Let's go ahead and look at how that works. Here I'm using a command called capture. Capture is a bit of a prefix command, and what it's going to do is, if I issue a command that has an error in it, my Stata program stops. Sometimes I want to trap that error or capture it and just know that there was an error but let the program keep running. For example, I want to issue the Stata command drop confidence 1. That's going to be my new variable. If confidence 1 doesn't exist, I get an error message. Let's just go down here and type in drop confidence 1. You can see I get an error message, variable confidence 1 not found. Now if I type in capture and the same command, confidence 1, if confidence 1 exists, it gets dropped. If confidence 1 doesn't exist, there's an error message, but it's captured by the capture prefix, and my program will keep running. So this is going to guarantee that I can make this new variable. Let's look at the guts of the variable. We've got generate byte confidence 1. Now byte is a new option that I haven't talked about before, but we did talk about storing our data in the most efficient way possible. I know that this new measure is going to range from 1 to 21. I'll explain how I figured that out. And I know that that can be stored as a byte variable, so the generate command lets me issue that right away and just declare it as a byte. I could also declare it as a floating point or double precision variable, but that would be an inefficient use of my storage space. So generate, and then the storage type, generate byte, and the name of my new variable, confidence 1. And we're going to let confidence 1 equal 31 minus the sum of 10 different variables: confidence in business, confidence in clergy, education, labor, press, medicine, television, science, legislation, and army. Why the 31? Well, think about what we did with the 3 variable index. We added those things up and found out what the largest value would be, which is 9. We took one value greater than that, and subtracted the sum from that value. So here I know that my largest, if I just were to do this confidence index without that 31 minus part of it, I would have an index that ranges from 10 to 30. And people with the most confidence would have scores of 10. That is, they'd be scores of, they would be responding 1 on each one of these variables. And people with the least confidence would have a score of 30 because they'd respond 3 to each of these variables. So confidence in business equals 3, plus confidence in clergy equals 3, plus confidence in education equals 3, and so forth. I take one value larger than that, 31, and I now calculate 31 minus that sum. So I should get a confidence index that ranges from 1 to 21, with values of 1 meaning the least confidence in these institutions, and scores of 21 meaning the most confidence. Let's go ahead and run this and see what outcome we get and check our variable. Oops. Here's our new confidence index. This is based across all the years of the General Social Survey. It looks pretty good, and we can even go ahead and create a little histogram quickly just to get a general picture or visualization. I'm using the percent option so I get percentages on my y-axis, and the discrete option so that each bar, 1, 2, 3, and 4, they don't get collapsed and they each have their own column. And here we get a nice view of American confidence overall with this scale, with values up at the high end of this scale having a great deal of confidence, and at the low end very little confidence. Let's go back to our program and look at one that a variable I've cleaned up a little bit and show you not a Stata trick, but a nice way to write your code. So this is probably the final code that I would use, and it's going to produce the exact same output that we had before, but it's much more legible or readable in my editor. So here I'm going to shorten the capture command to cap drop and a new variable confidence 2. Again, that just gets rid of any variable confidence 2 that exists. It's destructive, so be careful with it. I'm going to take my index using a generate command, and I'm going to wrap it in a pound delimit semicolon and a pound delimit CR, so that I can, instead of having this be on one line and kind of go off the screen, I can make this quite legible. And so you can see that, and it's easy to debug now because all my plus signs line up, all my variables line up. And you'll see this variable has a subtle difference. I'm using some additional commands in here, or additional functions. I'm going to take that basic idea of the 31 minus the sum of all those confidence intervals, confidence variables, but I'm then going to divide it by 21. Why 21? My maximum value is 21, and this will create a proportion. So it'll create a new measure. Our original measure ranged from 1 to 21. This measure will range from 0 to 1. I'll multiply that by 100, so now that measure ranges from 0 to 100. And then finally, I'm going to wrap all of that in a round function and round it to the ones place. So again, I'll get a byte value here, and I should get confidence scores that range from 1 to 100. I've got an error down here in my title, my variable label, and I'm going to fix that now. And then we'll go ahead and run this command. Okay, I've highlighted the capture drop, my generate command. I'm going to add a label, and then we'll look at a frequency distribution. There we go. So notice now that this confidence index starts at 5 and goes to 100. It could have started at 1. It didn't have to start at 5, but it's just sort of the way that this worked out when we divide by 21. And we've just expanded the scale a bit. I happen to like the 1 to 21 scale, but I just thought I'd show you this in case you ever had an opportunity with a lot of different variables, where this is more effective when you have lots of variables to calculate this kind of percentage. I hope you found this video useful, and as usual, if you have any questions, contact me, and I will do my best to answer them.
Then it's code in the D to give the keyboard a punch. Then cross, correlate, and a break for some lunch. Correlate, tabulate, process, and screen. Program, print out, regress to the mean. And it's, oh boys, can't you code it? Program it right. Nothing ever happened.